All right, ran out of time on the last video, so we'll continue with number 5 here. So now that we have our growth factor, we have to go and find our A value. That comes from right here. So at time equals 0 days, he had 100 followers. So I think we're good to go here. We can do f of t equals 100 times 1.314 to the t. Okay, and then a little tricky part here. It says that there's something here. Increases by 31.4% each week, but we're supposed to write our model measured in days. So to do that, we're going to have to divide our time by 7. Because remember, it's not going up by 31% a day. It's going up by that much per week. So to write our model, we have to divide that amongst the 7 days that are in our week. So that's our model there. And then next question, how many days will it take him to have the most followers on TikTok, which is 157 million followers? Probably the best way to do that is to graph 2 things. Graph this, and then also graph the line y equals 156 million, and then you can see where those intersect, and I'll put that up on Desmos here. All right, so here's everything plugged into Desmos. The problem is you're dealing with these super gigantic numbers, so it's a little bit hard to find it on your graph. So to fix that, you can just hit the wrench and then play with your X and Y axis until you get it. So I just changed the Y axis from 155 million to 157 million, so I could get within the right window here. And then you should be able to click and see where they intersect. So after approximately 365 days, which is approximately a year. All right, moving on to number 6. This time we have another model given to us, and then we're trying to figure out at what point will the bacteria, or the number of bacteria after 90 minutes. Okay, so once again, we have this model that's written in hours, and then we're looking for after how many minutes. So first thing, let's just write our equation. So we're going to do b of t equals our starting value, which we don't have yet. We don't have that starting value yet. So actually what we're going to have to do is use what we do have. We do have the amount of bacteria after 2.5 at time equals 2.5, and that is 5,100 bacteria. Okay. So to figure out what that starting value is, then they're actually using the letter K instead of A. E is our B in essence, our multiplier. Okay, so to figure that out, we can then just do 5,100 equals K E to the 2.5. Okay, well, this is just a number. We can figure out what that is, or so that we don't have rounding issues, we can just divide by e to the 2.5. Okay, once we do that, we end up with k equals, let's figure out what that is. Hop onto Desmos, and we're just going to do 5,100 divided by e to the 2.5, and we get 418.633. Or we could have just left it in fraction form so that we don't have rounding issues, but I think as we're just beginning this stuff, it's kind of nice to do it that way. Okay, so now 90 minutes. Well, what is 90 minutes in hours? Because remember, our whole model is written in hours. Well, 90 minutes is equal to 1.5 hours. Okay, so now what we can do is we can do b of 1.5 is equal to our k, which is 418.633 times e to the 1.5. And then if you plug that into your calculator, you're going to end up with 1876.185 bacteria. All right, that's all I'm going to do for the video. You can do number 7 and then do the, what else is on there? 7, 8 are 2 more word problems, and then 9, 10, and 11 are those different kinds of problems. So you can check the regular answer key on Schoology for those ones as well.